Graphs of trigonometric functions. We will begin with a number line. On this number line, I am going to plot some special real numbers. Those real numbers are going to be the measure of some angles in radian measure. Measure of angles taken in standard position. First we begin with 0 radian. So 0 here. Next is pi radians. Pi radians are equivalent to 180 degrees. Pi, value of pi is 3.14. So little above 3 we mark it. 3.14 radians are there from here to here. 1 radian is so huge till here. 1 more radian is till here. 2 radian now. 1 more radian till here. 3. And little further. That is why 3.14 radians. Whereas, if you go by degrees, very minute degrees, 1 degree, 2nd degree, 3rd degree, etc., etc., etc. If you go on, by the time you reach here, you get 90 degrees and 180 degrees till here. Degrees are very minute measures. So 3.14 is marked here, pi. Next is its double. If pi is 3.14, 2 pi will be 6.28, its double. And that angle will be 1 full rotation till here pi and 1 more pi till here. Full rotation. Next is pi by 2. Pi by 2 is the angle half of pi. So till here only. This is standard position angle pi by 2. So since it is half, we will be marking it exactly in the middle of 0 and pi. Pi by 2 is here. Next number is between pi and 2 pi, exactly in the middle of pi and 2 pi, we get this one, which is going to be 3 pi by 2. Here it is, 3 pi by 2 till here. So that is being marked here. Now, all these positive angles have negative angles also respectively. So if pi by 2 is here, minus pi by 2 is here. Pi here, minus pi here. Minus 3 pi by 2 plus minus 3 pi by 2 here. 2 pi and minus 2 pi. So this number line is modified. The thing is, we have plotted some special angles here just because we know the trigonometric functional values of these numbers. We may not know sine 2 radian. We may not know sine 3 radian. But we know sine 3.14 radian. Sine pi radian we know. So, trigonometric functional values of these angles we are aware of. Hence, to draw the graph of sine function, we will be using this modified real number line as the x-axis. Now, let's try to draw the graph of y equal to sin x function. For that, graph page is ready, in which x-axis is that modified number line. That is, some special numbers we marked on the number line. And y-axis is normal y-axis. Now let's have a table to write the x and y coordinates. For every x, the y will be calculated as sine of x, where x is standard position angle measured in radian. What is this? This gives us the idea of sine of the sine function, positive or negative. First quadrant, all trigonometric functions are positive, sine also positive. Sine is positive in the second quadrant. In third and fourth quadrant, sine function is negative values. Okay. Now, let's plot for 0 radian. When x is 0, y will be sine 0. Sine 0 radian is 0 itself. So the point 0, 0 can be plotted. Here it's already marked. 0, 0. Now we will go for next number, that is pi by 2 angle, pi by 2 radians. When x is pi by 2 radians, y will be sine pi by 2. Sine pi by 2 is 1. So we mark it 1 and plot here. Pi by 2, 1. On x-axis pi by 2, on y-axis 1. Point is here. Next we go for these three angles which are below pi by 2 radians. These three angles are pi by 6, pi by 4 and pi by 3 radians, which come in the first quadrant. Pi by 6 radian, pi by 4 radian and pi by 3 radian. They are in degrees, they are 30 degree, 45 degree and 60 degree actually. Now, let's go for pi by 3 radian first. If you put pi by 3 here, x equal to pi by 3, what will be the y? Sin pi by 3. And sin pi by 3 is root 3 by 2. Everyone knows it. Root 3 by 2 can be calculated as 1.732 upon 2. Root 3's value is 1.732 upon 2 gives us 0.866. So the y coordinate will be 0.866. So the coordinates ready. Pi by 3 comma 0.866. And pi by 3 is little below pi by 2. So here is the x-axis, x coordinate. And y coordinate little below 1.86. So this is the point plotted. Now come for pi by 4, which is still smaller angle, little smaller. From pi by 2, little smaller pi by 3, little more smaller pi by 4. Sin pi by 4, when x is pi by 4, y will be sin pi by 4. What is sin pi by 4? Sin pi by 4 is 1 by root 2. 1 by root 2, if you rationalize, it is root 2 upon 2. Root 2 is 1.414. Root 2 by 2, calculate and get the decimal value. That is little less than 0.8. 0.7 is less than 0.8. So the point will be plotted out here. Little smaller x coordinate, smaller y coordinate. One more angle we are going to plot, pi by 6. When x is pi by 6, sin pi by 6 will be the y coordinate. Sin pi by 6 is half. Half means 0.5. Plot 0.5 for pi by 3 angle. 0.5. This is 1 and half is exactly in the middle. So here comes that point. So we have plotted point 0 to pi by 2. 5 points we have plotted. And almost we got an idea of the shape of the graph. The sin x function for the first quadrant will go like this. From 0 going up till 1. Continuously going up till 1. This is the graph of sin x function for the angle 0 to pi by 2. First quadrant we have covered. And notice all the y coordinates are positive. That is why the graph is in the first quadrant, up above the x-axis. Now we will pass on to the second quadrant. In the second quadrant, let's more angles. From pi by 2, let's proceed further. The angles that we know, already well-known values are for angles 2 pi by 3, 3 pi by 4 and 5 pi by 6. In degrees, they are 120 degree, 135 degree and 150 degrees. Sine values are positive. We will use sine 180 minus theta formula to get these values. So sine 5 pi by 6 will be sine pi minus pi by 6. And sine pi minus theta is sine theta itself. So this will take the value of sine pi by 6 itself, that is half. So for these three angles, we will keep plotting the values. The same three values will come actually because they are also positive. Sin 2 pi by 3 will be 0.866. Sin 3 pi by 4, 0.774. Sin 5 pi by 6 is 0.5. Marking them in the table, and we mark the points. Pi by 2 to pi. Pi by 2 to pi, second quadrant. Second quadrant, we are drawing the graph from here to here. In this quadrant, those values, dekho, pi by 3 and 2 pi by 3 have same values. This height and this height will be the same. As it is going farther from pi by 2, it is also going farther. So, the shape of the sine graph will be like this. Second quadrant we have covered. Observe that by this time we skipped these integers. 1, 2, 3. We don't know the trigonometric function value of sine 1 radian, sine 2 radian, sine 3 radian. We don't know. So we skip them. We managed the graph using the values that we are familiar with. Let's pass on to the third quadrant now. Notice one very important thing. In the third quadrant, sine values will be negative. What will happen? In the third quadrant, first angle we'll deal with is 7 pi by 6, which will be minus half. Sine 5 pi by 4, third quadrant, minus 1 by root 2. And here minus root 3 by 2. The numerical values are these three only, but they are negative here. So as you go a little further, pi by 6 further, the y value should be minus half. So here minus half, the graph should come down. So the shape of the graph is going to be in the third quadrant, it will come down like this till minus 1. Why till minus 1? Because sine 3 pi by 2 is minus 1. Now if you go for the fourth quadrant, again negative angles are there. Negative values for sine functions are there. So the graph will be again below the x-axis. So third and fourth quadrant graph will look like this. This is the third quadrant till here and till here fourth quadrant. They both are negative quadrants. Negative values quadrants. So we got the graph of sin x function in the interval 0 to 2 pi. 0 to 2 pi means one full rotation. This is the shape of sin x function in 0 to 2 pi in one full rotation. Now let's go considering negative angles. Negative angles are drawn to the clockwise direction, this way. So minus pi by 2 till here, minus pi, minus 3 pi by 2 and minus 2 pi. This is a negative one rotation. Let's try to draw the graph for negative angles. Negative angles are plotted out here. So the three angles in this quadrant that we are familiar with is this: minus pi by 6, minus pi by 4, minus pi by 3. What will be their trigonometric values, sine values? In the fourth quadrant, sine value should be negative. So sine minus pi by 6 is minus sine pi by 6, so minus half. Minus half. Minus 0.5. So we will plot it minus pi by 3 minus half. The point will come here. Same with sine minus pi by 4 and sine minus pi by 3. All those values will come down here, and sine minus pi by 2 is minus 1. So the lowest point till here. Then pass on to the next quadrant in the negative direction. That is also a negative quadrant. So the values will be negative for that also. So the shape of the graph will go like this. From here to here is minus pi by 2 till minus pi by 2. And from minus pi by 2 to minus pi, the graph will be like this. Both are below x-axis because both quadrant angles are trigonometric values, sine values are negative. But if you still go further negative angle, we reach the third quadrant. There the trigonometric values, sine values are positive. So this graph will go to the positive direction, taking the same values. But only thing is, depending upon the quadrant in which the angles we are marking, the values will be positive or negative. Now we are further going minus pi to minus 3 pi by 2. Minus pi is here to minus 3 pi by 2. So the graph will go up. Likewise, here after one rotation, if you go further in the positive direction also, the graph would have gone like this. So y is equal to sin x function from minus infinity to plus infinity we can draw. The angles can be from minus infinity to plus infinity. The sine values but will go maximum up to 1 and minimum up to minus 1. So all possible values of x, right from minus infinity to plus infinity, we can take for x. That is why we say the function sin x has the domain minus infinity to plus infinity. All x values, any angle you take, its sine value is ready. But y values, as we have already observed, it will only take from minus 1 to plus 1 values, which is what we call range. All possible values of y collect together, that is called range. Range is the closed interval from minus 1 to plus 1. This is about sin x function.